Okay, the first steps in chromatography is that we're going to take our chromatography paper and we're going to draw start lines using a pencil on the chromatography paper. And this is where we'll place our sample. Start lines are drawn in pencil because this means that it will not run, it will not be soluble with the solvent, and therefore won't interfere in the results that we're going to do. I'm going to place my samples. There's my first one dot of that ink, and I've got a second sample, slightly different one, and we'll do a dot of that as well. Okay, so next what I've done is I've got my container, and you can see that I've put my solvent in. In this example here, we're using water as the solvent. And to help me set this up, I've got myself my two samples and I've fastened it to a splint using paper clips. Now hopefully I've measured it, because what I need to happen here is the water needs to touch the bottom of the paper without touching the ink sample that's already on the paper. So I'm going to lower this in, just checking to make sure it touches without the ink, and you can see already the water is now moving up a chromatography paper in order to reach the ink, and the ink will then be soluble and move up the paper with the water. This just shows you the setup that we have, and to remind you, we have our beaker that's containing our solvent, and in this experiment we're using water as a solvent, and the water is going to move up the paper to be absorbed up the paper. So therefore the water is the mobile phase because it's moving up the paper. Here you can see again there's our sample. So as the water comes up, the sample will dissolve, it'll be soluble in the water, and then it'll be carried up through the paper. And then the chromatography paper itself, this doesn't move, so therefore this is referred to as the stationary phase in the experiment. So here are the results from our chromatography experiment, and you can see where this is where the start line was initially drawn and my sample, and then you can see the trace that's been left behind as the ink starts to separate out. This one has a very similar set of inks in it, slightly different pattern but similar set of inks in it for this second sample. And what you'd normally do at this point is you can calculate some RF values. So if I pick this purple colour here, probably the most sensible way to do this is you take a point halfway in that sample, so kind of there. And remember, to calculate the RF value, you measure the distance from the start line to where your ink has travelled. So for me, that's 5 centimetres. And then you measure the distance from the start line to my solvent front. Now I've actually drawn a second line here because this dries out and then you can't see where the solvent stops. So I've drawn a line here and I can see that that is 5.7 centimeters. So I do 5 divided by 5.7, and that would give me my RF value for this particular ink in this sample here. This one's a mixture because we've got these different colors, as is this one. If it was pure, you would only have one color pattern being produced by the ink. Okay, so here we have the result from the experiment, and you can see I've labeled the start line to show where the sample started. I've added the solvent front here to where the solvent has travelled up the paper, and then we can see the different colours of ink that have separated out in my mixture. I'm going to show you how to calculate that RF value, and I'm going to use this pink colour here as an example of how to do that. So first of all, I measure the distance from the start line to where the ink has travelled to, and I'm taking halfway of that ink as my marker. So that distance there is 5 centimeters. And then I measure the distance from the start line to the solvent front, and that distance you can see here is 5.7 centimeters. So to calculate the RF value, I take the distance that the dot has travelled, and I divide that by the distance that the solvent front has travelled. So let's put those numbers in. So the distance of the dot is 5 centimetres. The distance that this solvent front has travelled is 5.7 centimetres. Work that out using your calculator and it gives you an answer to two decimal places of 0.88 as a value for RF. Always worth checking. This value here should always be less than 1, and that just confirms that we've done the calculation correctly.